Hello everyone, your Dr. Zia Tahir here. This video tutorial is plane truss analysis in Abaqus CAE. Truss is a three-member as shown in the figure, so that is a plane truss. All members are made from steel with the modulus of elasticity 200 gigapascal, Poisson's ratio of 0.3 and cross-sectional area of each member is 2300 millimeter square. To determine deflection of each joint, normal stresses for each member, reaction at each support, and axial force in each member under loading condition. This truss is a work example from Chapter 2, Bar Elements, Introduction to Finite Element Analysis using MATLAB and Abaqus. So this is a book, Introduction to Finite Element Analysis using MATLAB and Abaqus, and that is Chapter 2, and this is a work example. Here you can see this is a work example, and I'll use results from this example to verify. Like as here you can see that the reaction forces, they are here, and then deflections are given, so and then member forces are here. So these are the member forces. So the results from here, so they will be used to verify Abaqus modeling. Three main steps in analysis in Abaqus CAE. The first one is modeling, then analysis, and then results, and these are the highlights. So create a part, create material, create section, assign element, assign section, create mesh, create instance, create step, modify field output, create load, create boundary condition, create job, and then run the job, and finally visualize results for displacements, stresses, reaction forces, and then to calculate member forces. So these are steps which I'll follow one by one. Before starting, you need to make sure that you have correct set of unit, because Abaqus doesn't have any set of unit, so you have to select your own unit. So units may be Newton meter pascal, or Newton millimeter megapascal, or Newton per millimeter square. So you need to set your own system of units based on stresses, loads, and dimensions. So in this problem, dimensions are in meters, areas they are in millimeters, and stresses are in pascal. So for this problem, I'm going to set dimensions in millimeters. So I need to convert that meters into millimeters. So they are very simple: 4000 millimeter, 6000 millimeter, and then because area is in millimeter, and then Poisson's ratio is a unitless, and modulus of elasticity 200 gigapascal, so that will go 200 into 10 to the raise per 3 megapascal, or 200 into 10 to the raise per 3 Newton per millimeter square. I am going to use here Newton millimeter megapascal or Newton per millimeter square. The next one, you need to set a work directory. So work directory you need to set where you want to save your model and where you want to save all your results. So here I have Abaqus CAE 2020. So the first step is to file and set work directory. That is the folder plane truss 3 member. I want to save all model and results here. So just copy it from here and then paste there. And okay, so now work directory is being set, and I'm going to save that model. Plane truss 3 member, and okay, so now it is being saved. Step now is to create part, and it is 2D deformable wire, and approximate size need to keep at 2 times maximum length, and then create lines connected. So that these are the steps. So I'll go here. So now you have 3 options here. Using tabs, here you can create a part, then in the module need to click here to create a part, or you have in model tree you have double click to create part. Okay, so part is 2D deformable wire, and approximate size will be the maximum dimension. So the maximum dimension is 6000 times by 2. So if I add there 12,000, so it's not going to add because the maximum it is going to take as 10,000, and I named that as truss. So plain truss, and now need to sketch. And here you are 2D deformable wire. So, and then you need to create lines, connected lines. So here you can use that connected line. So I'm going to draw the first diagonal line. So you have two options here. Either you can enter here the values like as origin 0, 0, that is the starting point, and then the ending point is 4,000 and 6,000. So now you can see you have here first line, and then you can use mouse for the other ones, and mouse wheel used to zoom in or zoom out. So that is a second connected line, and then that is a third connected line, and you can see that there is H on it, so it shows that is a horizontal. So once it's done, then you need to cancel procedure, and then here sketch the section for the wire. So it is done. So now you can see that part is being created. So that is a truss. So, and here you can see that, so that part is being created. Next step is to create material, and that material elastic, type isotropic, and need to add modulus of elasticity and Poisson's ratio. So here you have options, three options there. So either you can here click on the material, that is the first option, or here using module property you can create a material here, or otherwise you have here material, so create a material. Okay, so material name, I'm going to name it as steel, and then here you have mechanical, elasticity, and then elastic. Need to add modulus of elasticity, which is 200 e raised per 3 megapascal or Newton per millimeter square, and the Poisson's ratio is 0.3. So here you can add the values. Okay, and then you can see here the material is created. So that material is created. Next step is create section, and the category is beam, type is truss, and need to add cross-sectional area. So to create section, so you have here again in the property module, you can click here to create section, or you have option here to create section, or in the model tree you have section here. So just double click on it, and section is beam, type is truss. I'm going to name it as truss. So continue, and then here material is steel, and you need to add cross sectional area, which is 2300 millimeters squared, and click OK. And now you can see a section has been created with truss. Step, using property module, you can assign section, and you need to select region and then select section. So you have options here. You can go here and then assign section, or you can here assign section. Okay, and now it asks you here select the region to be assigned section. So I'm not going to create any set, and then I'm going to select whole of this region, and it says done, and then here is a truss, and OK, and here done. So now section has been assigned to truss, that is your truss, the section has been assigned. Next step is to create mesh, and here is the seed edge by number should be 1, then mesh part, assign element type. So here you have again options. You can here go to property module, and then you can mesh it, or here you can create mesh, or otherwise you have here in the model tree, so you can create mesh. And then when you select create mesh, then you have here seed edges option. So I'm going to select seed edges, and then it says that select the region to be assigned local seed. So I am going to select whole of this region, done, and then it gives you option. So mesh by number, and then number of elements you need to select as 1, because in theory there must be one element between nodes for truss elements. So then I'll apply OK, and then the next one here you have option of mesh part. So mesh part here you can, it says that OK to mesh part, so yes. And then here you have assign element type. It says that select the region to be assigned element type, so I'm going to select whole of that, and then done. And now I have options here. So family, in the family I need to select truss, then element library standard, geometric order standard, and then it is the T2D2 a 2 node linear 2D truss, and then I'll select OK, and then done. So now it's being meshed. Next step, in the assembly module need to create instance or create instance from parts, and need to select parts. So again you have here option. So here you can go in assembly module and create instance there, or you have here in create instance, or otherwise in the model tree, so you can go and create instance. So I am going to start from here. So click, and then it says that create instance from truss part. So I'm just going to select OK, and then here in the assembly you can see that plain truss is there, so that instance is being created. Is to create step. So step means that which type of load you want to apply, and procedure type is journal, and then static journal, and I'm going to name that as static load. So you have again options here. So like as you can go here, and then in the step module, or you have step here in the tab, or otherwise you can have here in the model tree step. So I can create step from here, and now you have option here. So name, and then is a journal, and then static journal. To name at static load, continue, and then I'm going to leave everything default values, and you can see there static load is being created in the model tree. Next step is to either create field output or to modify field output. Stresses, displacement, and forces are required, and for this one here you have field output requests in the model tree. So I am going to just click on field output, and then you have here few stuff, domain, whole model, and then I am going to select stresses. I'm going to unselect strains. Contact I'm going to unstress. So you have either empty or a tick, or then a box. So for the stresses I have only selected one part there. For displacement I have selected only translation and rotational displacements, and for forces, reaction forces and moment, and concentrated forces and moments, so I have selected these ones. So once you have modified it, so I click OK, so it is being modified. Next step is to load module, create load, and step is a static load which you have already defined in step. Category mechanical, type concentrated force, and then select a point where you want to add apply load. So again you have here load module. So this is, you can create a load, or you can create a load from there, or down in the model tree you have load here. So I'm just going to double click it, and then you will have load. So you can name the load. Step is a static load which you have already defined. Category mechanical, concentrated force. Continue, and then select point for the load. So I am going to select this point here, and then it's a selected, done, and now it asks me about what are the forces. So a force of 12 kilonewton is being applied at point 3. So in horizontal axis, that is 12 e power 3. So 12 kilonewton. Concentrated force 1, and then 2. 1 mean x-axis and 2 mean its y-axis. So okay, so now this load is being applied, and you can see that here a load 1 is being created. Next step is to create boundary condition using load module. So step is initial, category mechanical, type displacement rotation, and select the region for it. So here I have options for it. So in the load module, you have the second one is create boundary condition, or otherwise you have here to create boundary condition, or in the model tree, you have here to create boundary condition. So double click on it. So now the boundary condition name is BC1 and step is initial, category is mechanical, type is displacement or rotation, and then I need to select a point where I want to apply boundary condition. So at node 1 is a simple sport. So simple sport, it means there are two reactions. So I am going to continue, and then select the region for the boundary condition. So I am going to select this, done, and then here you have option. So U1 and U2 need to be constrained here. So okay, so now you can see that here boundary condition is being applied, and I'm going to, so I renamed that as pin, and now here I can create other boundary condition. So create, and then this boundary condition I am going to name it as roller. So step is initial, mechanical, displacement, rotation, continue. I'm going to select this point. So done. And on roller sport, displacement in x direction is free. So U2 is 0. Okay. So now you can see that one pin sport applied, one roller sport is being applied. So modeling part is done. Next one is analysis. Job, need to create job, data check and submit. I forgot to do one thing. I need to rename that model. I'm going to name it as plane truss, and then here in the module I have here job. So I can create a job here, or otherwise you can create a job from there. So let's say create a job, and job name is plane truss, and then model is plane truss. So continue, leave it as it is, and then you have here, so plane truss. So you right click, and then you need to first do data check. So data check will help you to check if there is any major problem in the model. So, and then it takes some time, and then you can see that data completed successfully. So there is no error, or it's not being aborted. So then I can go and submit. Okay, so okay, and now that is being submitted. So it takes some time to finish. So it's running, and then once its status changed, so you can see that completed there. So this is completed now. Job is complete. Next one, in the results, you need to visualization, field output dialog, displacement as U, stresses as 1, then reaction forces. So it's simple. There are different options. You can go here and click on the results, and now you can see here is the plane truss ODB, or otherwise you can go here file, and then you can open an ODB. Okay, and then it will, so select that and open. So that is ODB, and now here you can see that in ODB, so that is a model. So that is deformed model, and then here you can see that, so that is with the contour. So you have option here, so you can plot here deformed and undeformed, and then here you have option. Okay, so that is field output dialog, and that is a primary. So you can select U from here. U1, it's a magnitude in horizontal direction, U1 in vertical direction, or then magnitude of it, otherwise stresses, and S11 is the axial stress which we are looking for. And then here you have concentrated forces, you have reaction forces. So this is like we need reaction forces, we need stresses. So that's why in the field output dialog, so all these are being displayed. Next step is visualization for displacements. Okay, so you can use prob values. So prob, nodes, components, all, display group all, and then you can write to the file. So now here you have two options to go to the prob. So first you need to select here from the field output dialog. From the field output dialog, you need to select U and then like magnitude, and then you have either here tools, query, and then in query you have here prop values. So when you are going to get that prop value, so you have option to select from viewport or select a display group. Because displacements or deflection are at nodes, I select that component all selected, okay, all, and then display group all nodes. So now you can see that here are the values on the nodes. So I am going to just display model, and then I select all that, and you can see here, so deflections at these points, they are almost 0. 10 to the raise power minus 32, they are 0, but there must be a deflection at that point. So horizontal is 0.96355 and the vertical is minus 0.233. So you can see here, like U3 and V3 in horizontal direction is 0.9635 and the other one is in vertical direction is minus 0.2348. So the same values which you got, which are in the book, so we are getting here. So one thing you want, so these are the values here. So then you can write those to a file. So all that value you can write to a file and you can create report, and that report is being saved in your work directory, and from here you can change number of significant digits, number format automatic engineering, so I'm selecting engineering, and then it say write total column totals or column minimum. I'm going to select both of these two, and then I'm going to name it as Truss plane. So now that is being saved. Okay, so you can see that here you have that report created, and then you can open that report in as a text file using any of the software. I'm using Notepad, and you can see here like at nodes how much is deflection, and that is in millimeter, and then the minimum where is it, and then the maximum where is it, and the total. So I am going to close that report now. In the visualization I need axial stresses, and for that I need to select S11 and prop values, and stresses are on the elements. So I am going to cancel it. So cancel, and previous one I am going to clear. Now from here I'll go S here and then S11, and now here I have prop values now again. So prop values, and then here I'll select elements, components all direct, and then centroid, and then all. So you can see that there are 3 elements, and for each element the values you can see there. Okay, so these are the values. So like as these are the values, these are stresses, and I'm going to write to file and now append to the file, so which is already created, so it is going to append that add there. Okay, and then I'm going to cancel it. Yes, to continue. Is to find reaction forces, again prop value, and I'm going to show you here how it's going to be. Here you will go RF reaction forces magnitude, and then here you have prop values, and reaction forces are on the nodes and components all, and then all, and here you can see, so these are the reaction forces. So there is no reaction force on node 3, but at node 1 and node 2 you have reaction forces. Let me check that what are in the book. So force in horizontal direction at node 1 is minus 12 kilonewton, node 2 in vertical direction is minus 18, and at node 2 is 18 kilonewton. So the same values we got here, so minus 12,000, minus 18,000 and 18,000. So the reaction forces are also verified. Next step is to create a report of using field output for the variable S11 and export to Excel and calculate member force. In Abaqus you can't get that directly member forces, so you need to then create a report for stresses, which I have already created. So I'm going to show here. So what we have here for, and you can see that. So here the second one, this report is written, and then these are stresses. Okay, so these are stresses and these are the values of stresses. So I am going to import that file in Excel, and then I calculate axial force. New Excel sheet I have opened, so I'm going to just copy the stuff from there and paste here. And now in the data, I'll go text to the columns and then fixed with any denominator. Okay, so here, next, finish. So now these are the two stresses or stresses, and then I need to multiply that with area. So that is minus 18,000, and then the other one is 21 kilonewton. So I can check that here, the member forces. So here are the member forces. Okay, so the member forces, you can see in that this member 3, which is let me show here what are the members. So labels, show element labels and no label, apply, and that is member 3. So in member 3, you can see that in member 3, so member force is 21.633 kilonewton, and you can see that it is the same value which you have here. Okay, so member force, that is the third one, member force, in third member force, and then similarly for the second member. So the member force for the second member can be computed as, which is we have here in here, so that is 18,000. So now this way you can calculate member forces. Recap and summary of the tutorial. So this tutorial is 3D plane truss analysis in Abaqus CAE. So dimensions of the members, mechanical properties are given, and required is deflection, normal stress, reaction force, and axial force. So you can find these deflection, normal stress, and reaction directly, but axial force you need to calculate. And these are the three main steps: modeling, analysis, and results. So most important, there are no set unit in Abaqus. You have to set your own unit. You need to set work directory and save model. And then the first is to create part, then create material, then create section. So section is which type of equations you want to use to solve particular problem. Then you need to assign section to your created part. Then you need to create mesh, and for trusses there must be, as per theory, there must be one element between two nodes. So then we need to keep that one member element between two nodes, and then create instance. Instance is to combine your different parts to get assembly, but here we have only one part, so then there's no need of going for complex assembly. Then create step. The step is mean that which type of load you are going to apply, and then you need to modify field output or create field output, that which output parameters you need. And here I'm going to I use stress, displacement, and forces. And then you need to create load or simply apply load. Then you need to create boundary conditions, and then create a job, and then you can, after creating jobs, so you can perform data check and then submit. So once it's being submitted, you can go to the visualization of the results. So you can visualize those results in the viewport, and sometime you like here, then with the prop value you can first visualize deflections, and then you can write a file, report file on that. Similarly for stresses, similarly for reaction forces, but for the member forces you need to first extract a file, report file for S11, and then you need to multiply with area of cross section to get values. Thank you very much for watching this video tutorial. I hope you find this video tutorial helpful. So if you have any feedback, you can leave in comment section. Thank you very much.